Thank you. It's great to be back in Croatia at Shift. This is my second time here. And this is safeguarding sensitive data in the age of generative AI. So LLMs, basically, unless you've been under a rock for the last year, is the new thing. This is what everybody's talking about. In fact, I don't even think this stage existed a year ago at this conference. I think the stage was probably blockchain and crypto, and that stage doesn't even exist anymore. So a lot has changed in the last year. And actually, this is something that's touching everybody's lives, not just essentially, the tech people in the world. I recently traveled back to my hometown in Canada. My father, who's in his 70s, is now retired. The first thing he said to me when he picked me up at the airport was, what's this whole thing that's going on with AI? Is AI gonna kill everybody, essentially? And if it's touching the retirement community in rural Canada, then it's touching everyone. So this is a really, really big sort of thing that's happening in the world right now. But of course, with any new innovation, there's a lot of different challenges, especially when we start to think about privacy and trust and ethics, and that's kind of what we're gonna be talking about today. But before we get there, just to kind of level set for everybody, and I'm sure some of this stuff's gonna be super, super basic for people who are working in this space, but there are some sort of basic concepts that are important to understand around large language models that'll help facilitate sort of the conversation, some of the things I'm gonna be talking about. So these are essentially foundation models, fine-tuning, inference, and there's a lot of other things, of course, but these are sort of the basics. So the foundation model is essentially the general purpose model that's trained on tons and tons of data. This is like what we're used to experiencing when we use systems like ChatGPT. And in a lot of ways, this LLMs today, these like general purpose models, they're a little bit like my 3.5-year-old, where if he had perfect memory and has read everything on the internet, essentially, but sometimes he makes things up to suit his purposes. Or in the terms of you can think about it from art. This would be the slab of marble that you begin doing your sculpture work with. Essentially, the slab of marble is the general purpose model that you're starting with. Whereas fine tuning is essentially, now we're gonna craft that model into something that's more domain specific or problem specific. So keeping with our analogy of sculpting, we take this slab of marble and we chisel away at it to turn it into something that's like a representation of a person or a cat or whatever it is that we want to create and sort of fine tune to our vision or the problem that we want to solve. And then finally, inference is the way that we interact with the model. So we're sending essentially questions or prompts or instructions to the model, and the model is going to execute and generate some sort of response. Or with our sculpture, essentially, we now have our sculpture inside an exhibit at a museum, and we're sort of interacting with that model in the context of the museum, and there should be able to answer basic questions about the sculpture. So those are kind of like the baseline concepts that are important to understand for when we start to talk about some of this stuff. So what does this all mean for our industry? So clearly, this is having a big impact on the way that we engineer products, and also lots and lots of other industries, the way that we create different experiences for people. And throughout history, every decade or so, there's essentially new paradigm shift in how people sort of interact with technology. So going back to mainframe computers, to desktop computing, to the internet era. And there's a lot we can learn by looking at those previous times in terms of how the industry and how different people reacted to that, and also how people innovated. So going back here to the internet era, essentially people said, we're promised instant shopping. We'll order airline tickets over the internet, make restaurant reservations, stores will become obsolete. So how come my local mall does more business in an afternoon than the entire internet handles in a month? So clearly this person was very, very wrong about what was gonna happen with the internet. But that was the sentiment of essentially the old guard that existed back in the 90s when the internet was becoming really big. And I was lucky enough to be in high school when this was sort of catching on. And I got to experience the pre-internet era, the disconnected world, as well as the connected world. And it changed everything. And also, of course, dramatically changed my life because I became obsessed with the internet and coding. And it took me on a particular path that leads me here today. But the businesses that realized the potential of the internet, that were able to either transform their businesses to become internet businesses, or the new types of companies that essentially sprung up during that period, they left all the sort of dinosaurs of the disconnected world, in their path. And most of those companies died or just became essentially irrelevant. Fast forward a decade, We're into the mobile era. People will maybe browse, but nobody will buy. How many people have bought something using their smartphone? Exactly. So pretty much everybody. But this was the sentiment at the time. People didn't think that anybody would ever do something like book an airline ticket on a smartphone. And I created a company during the early days of smartphone or early mobile. And that company was essentially a two-sided marketplace for job seekers to find jobs and for people to post jobs. And we were the first company to ever create an end-to-end experience on a smartphone to apply to jobs and basically handle job applications. And at the time, all the incumbents thought no one would ever apply to a job on a smartphone. Why would they do that? They have a desktop, it's so much easier. But we knew that that was wrong because, one, we actually talked to people, and then we also recognized that the next generation of essentially internet users, people in their like 20s and late teens at that time, their main way of interacting with the world was essentially a smartphone. So there was going to be this huge transformation that happened, and we've continued to see that, through time. And essentially all the companies that existed before got killed by the mobile first companies. And then in the cloud era, which we're still very much in, essentially it wasn't that companies didn't think that there was value in cloud services, but they were nervous or scared about how secure could it be. And their reaction was, we're not going to rely on AWS or other sort of cloud first companies. We're going to go and build our own cloud. And we'll compete with those guys. We'll compete with Salesforce and ServiceNow and so forth. Of course, what ended up happening was most of those companies or most of those projects died eventually because they became really hard. They couldn't stay competitive. They actually had more security issues than the public cloud has. And now even banks like JP Morgan are in the process of essentially moving everything to the public cloud. So this was from 2017, JP Morgan, Chase, big bank in the United States, finally saying like, hey, public cloud, there's actually something here. We're gonna actually start to move over to that and move a lot of our applications to run on AWS, run on Google Cloud, and so forth. Now, in the LLM era, we're also having a big transformation that's happening right now. And of course, there's ChatGPT, which I think has really brought the idea of generative AI and also LLMs to the forefront beyond just the tech world to people like my parents. There's Cohere and Cohere Playground. There's, of course, GitHub Copilot. And as you saw even in the previous talk, or if you're at Sean Wang's talk earlier today, these things are having a big impact in the way that we even think about developing software. But of course, it's also having impact on things like biotech and the way that we do drug discovery. And it has potential to have impact across many, many different industries. And I think one of the things that we can learn by looking back at a history of these different eras is that whatever our predictions are now about what impact this will have and what the innovations are, they're probably going to be wrong because we were wrong multiple times in the past. So we're probably underestimating really what this might mean for our future. But with all this, there's of course, we have a major problem. And this happens sort of like with any sort of new type of innovation. But with LLMs in particular and the notion of neural networks, it's a new type of problem that we've never really dealt with before. Because this is a new type of technology that really we're not used to sort of building and developing applications for. And that problem essentially is that unlike a database, which we're all sort of used to, the AI model doesn't have a delete button. So once you share sensitive data about a customer, an employee, yourself, core IP for building a foundation model, fine-tuning, even in some cases inference, you can't take that back. It's a little bit like me asking you to delete the part of your brain that knows what an apple is. You're not going to be able to do that. So what that means from a privacy standpoint is it's going to be very difficult for you to move beyond proof of concept, beyond demo in anything in this space unless you have an answer to this problem. So we've already seen a bunch of, these are headlines from the past year of various privacy challenges. Basically, Italy shut down the use of ChatGPT for a little period of time. Companies like Samsung, Apple blocked the use of ChatGPT for a period of time because people were sharing essentially core IP with it. But those are really just band-aids to this sort of fundamental problem. At the same time, there's also this like convergence of AI architectures going on right now. So earlier this year, from Andreessen Horowitz, they came out with this emerging LLM stack It's kind of hard to read, but basically you have a bunch of data that comes in at the top, an orchestration layer that's going to do your training, building your model, fine tuning, and then you have essentially ways of interacting with that model through an API. And there's different, techniques that you might do there, where you're using either open source models or you're using, something that you're running on the cloud. But there's no notion of essentially privacy or trust as part of this stack today. And then in June, Salesforce came out with the launch of Einstein GPT Trust Layer, which essentially is their view of how to introduce security into the development of models, in particular running on Salesforce. So here they have a secure gateway, essentially, of how to essentially filter out sensitive data that you might have in Salesforce that you're using for training. And then all the public clouds are essentially telling you, our solution is run your model privately within our infrastructure. So this is Google Cloud, run it within a tenant within Google. AWS, the same position. Microsoft, the same position. But besides these, essentially being somewhat self-serving, they're saying like, don't trust the open source, open available LLMs, foundation models. Don't use those. Come to our services and run your private version of LLM, your model within our infrastructure. And in a lot of ways, that is like the notion of building your own version of the cloud rather than essentially building on the public cloud. And that, I think, is going to be a losing scenario. But also, the problem here is that the idea of private LLM, even though it sounds good in some ways, is not actually privacy. A private LLM run in basically gives you model isolation. It doesn't give you privacy or fine-tune access control. And privacy is about control of my data. If I have a private LLM, I can't solve fundamental problems like making sure that Susie in accounting sees one version of the data, and Bob in marketing sees a different version, and someone in customer support sees a different version of that. What matters from privacy standpoint is who sees what, when, where, and for how long. And you don't get any of that with private LLM. So private LLM, while it gives you some notion of protection versus sharing that data, maybe with, if you don't trust OpenAI or one of these other providers, it doesn't solve the privacy issue for your customers or the consumers of the model. Now, through sort of history of data, we have lots of different types of data. And we've started to recognize that essentially not all data is the same. It's not all just zeros and ones, essentially. And we've developed different technology for specifically handling special types of data. So we have KMS for like encryption keys, secrets managers for secrets, identity cloud, or providers like Okta for passwords. But when it comes to essentially PII data, even outside of the world of generative AI, we don't have like an industry standard for managing, using, and securely storing PII. We basically put it in a database with all our application and transaction data, and then hopefully layer on some forms of security, cross our fingers, and hope that we're doing an okay job. So this is a big gap in terms of how we think about the landscape of data. But luckily, companies like Google, Apple, Netflix, a handful of others have started to recognize that PII data is also something special, similar to something like secrets or encryption keys, and it needs special handling. And it doesn't belong essentially intermixed with all our regular application data. So they've pioneered this technology of a data privacy vault. And last year, IEEE came out with this article about the future of essentially privacy engineering, where they said the future of privacy engineering is this architectural approach to privacy, of essentially making a data privacy vault the core infrastructure for your PII. So just like you would have a database, a warehouse, an API gateway, all these types of things in a modern system, if you're handling customer data, you also need a data privacy vault, which gives you isolation, protection, governance, and use over essentially that sensitive data. So this is kind of the missing piece of the puzzle in essentially this landscape of sensitive data. So this is becoming more and more of essentially a standard of how big companies and even small companies are starting to essentially handle sensitive data. And this is in the yesteryear world of databases and so forth. But what we want to look at essentially is how can we apply this to the world of generative AI? So one of the other things that you get with a data privacy vault architecture is fine-grained access control. So this gives you essentially the ability to control who in marketing sees what, and someone in customer support sees a different view of that data. And essentially, you're taking your existing systems out of scope where they're only essentially accessing pointers in the form of de-identified data. So the vault becomes the single source of truth of your sensitive data, and then essentially you govern access based on policies that you build up through a zero trust model. So that's sort of the core concept of this. And what we're going to look at is how can we apply this idea to the world of generative AI so that we can essentially have control and introduce privacy into the types of products that we build based on LLMs. So we're going to first look at model training. So in model training, essentially, you're starting with a whole bunch of data. And this could live in any sort of like data store. These are just examples. But you have a mixture potentially of sensitive and non-sensitive data in there. And what you want to do in essentially the world of a vault is part of this sort of, it's basically an ETL process down to where you're doing model training, is you're going to send that data first through the data privacy vault. And the vault is architected in such a way that it can do detection of PII. You can even do things like core IP detection. And we're going to pull out any of the sensitive data and store it within the vault. And then through essentially a combination of various privacy enhancing technologies, things like polymorphic encryption and tokenization, we can create de-identified data, essentially clean data, that has referential integrity and also enough contextual information that we can do model training with it. Because the model doesn't care that it sees my name, Sean Falconer, versus ABC123, as long as essentially we're creating that same de-identifier every time Sean Falconer is the input. So we can create essentially de-identified data that has referential integrity and even contextual information to let the model know that that's a name or an address or whatever it is that you need to tell it. And then when it comes to model inference, so essentially the interaction layer with the model, and this is an example where we're giving an instruction to let us know summarize essentially a will. The will has a bunch of sensitive data in it. So what we're going to do is essentially send the prompt through the data privacy vault where we're going to identify the sensitive data, replace it with these de-identified forms of the data, and send essentially this de-identified version of the prompt to the model. And since the model is already trained with de-identified data, it's going to essentially be able to actually process that and perform the inference the inference operation as we want. And then on the reverse, we can re-identify the data if it has these data identified forms based on essentially the policies that are placed within the data privacy vault. So this gives us essentially almost like a firewall into the model and also in the reverse direction where we can apply these policies so that we can have essentially fine-grained access control over this. And this gives you the control where you can have your customer support agent have one representation of this response, and someone in marketing or administration or the CEO of the company have a completely different version of that response. All right, so now we're going to actually take sort of this concept and see some of this in action. So we're going to look at an actual demo of this. So the demo is a medical health customer support scenario. So we have essentially a customer support portal where patients come and they ask the customer support agent for different questions, and the customer support agent can use an internal AI assistant to help them answer questions and parse information about the patient. So we are using essentially an AI-based assistant that's going to use an LLM behind the scenes, and we've trained that using creating essentially embeddings that augment the foundation model based on patient data. And then we're essentially performing privacy-safe inference using the data privacy vault in combination with the LLM. And then we can also use policies to control access to that. So customer support agent probably doesn't need access to all the information about patients, and they only need access to the patient records that are currently in their queue that they're interacting with. They don't need access to everybody, essentially. So in terms of how I built this, the front end's Next.js, kind of standard stuff. Back end's Django. The LLM stack is OpenAI and ChromaDB that I use for creating the embeddings. And then I'm using Skyflow, which is a data privacy vault provider. All right, so I'm going to skip over to, let's make this bigger, the demo here. Oops. Someone's messing with my mouse. Uh-oh. Let me try one more time. There we go. All right. So this is essentially the customer support portal. We have patient information there. They're asking a bunch of questions. And I'm going to skip over to, All right. This is, can't click on anything. All right. This is the danger of live demos. Okay, well, anyway, we'll dance around this a little bit. So I can't actually invoke any of this because my mouse is not working for some reason. But what I wanted to show was essentially everything that's highlighted in blue here are essentially the PII information. But what actually is going into the model for inference and also for training is essentially the de-identified version of that. So we're basically replacing any of the John Doe, date of birth, and stuff like that with a representation of that information that has no sensitive data associated with it. And if this was working, I could actually show the GPT data. So we're gonna have to skip back here to, this isn't working. I'm gonna unplug this for a second so I can rerun my slideshow. All right. Oh. See if we can get this back. There we go. All right. I'm probably freaking out the tech team in the back there. But anyway, so what's actually happening behind the scenes, unfortunately the demo didn't work as described because I couldn't actually click on anything, but what's happening here in terms of training was I took a bunch of the raw data, which is these patient records, and essentially I'm creating an augmentation of the foundation model where I'm running that raw data through Skyflow, pulling out any of the sensitive data and essentially creating clean data on the other end. And then I use Snowflake to create an ETL pipeline to push those patient records basically into a Snowflake warehouse. And from there, I'm using LangChain. LangChain has a Snowflake document loader. So you can essentially use that to pull the documents out of the warehouse and create essentially a vector representation of those that I'm storing in ChromaDB. And we're using that to essentially augment a out-of-the-box model from OpenAI. And then on the inference side, what's happening is in the chat input, essentially when I type in something like, what is John Doe's date of birth or something like that, we're going to send that to Skyflow. Skyflow is going to replace John Doe with essentially that de-identified version of the data. You can see here just an example where we're just essentially on the SDK calling Skyflow.detect, which is going to essentially replace any of the sensitive data with the clean form of that data. And then we're sending that clean form onto the actual perform inference. So first we're grabbing the embeddings from ChromaDB, and then I'm using Retrieval QA, which is a class from LangChain, to actually perform the inference. So here, basically grabbing the clean input, running the inference operation here, attaching the vector store there as the retriever. Pretty simple stuff. And then essentially once we get the response, we would send that back through Skyflow as well to re-identify anything and apply the policies that are in place. So that's essentially the general principle. It's like using this proxy or this firewall to protect the LLM, both on ingestion, basically the ingress and the egress to the model. So kind of the moral of the story of what the point I'm trying to make is that you never want to send PII, personally identifiable information, into a model because the model never forgets. Basically, once it's there, you can't really get it out. But by essentially combining the best technology that exists in the world of privacy engineering, you can create privacy-safe AI. So we can combine what we've learned from the world of essentially data management, data engineering, and apply that during model training, during fine-tuning, during inference, to provide this protective layer over the products that we create. And that's going to allow us to essentially move beyond proof of concept, demoware, to actually being able to create products that we sell into enterprises, because you're never going to be able to essentially sell into an enterprise and have that become a real product unless you can answer these challenging sort of privacy and trust questions. So I want to thank everybody. Oh, there we go. Thank everybody so much. Sorry about the demo. If you want to check it out, find me, and I'm happy to show you live where my mouse works. But also, if you have questions, I'll be here through tomorrow. But you can also reach out to me on email there, or any of your social media platforms. And if you're interested in topics of like privacy, security, engineering, I host a podcast at skyflow.com/podcast, and there's also a community attached to that where you can check some of the stuff out. But thank you so much.